At this point, we have examples of the speaker in a box and the power amp sections, but now we want to focus on the more front end of the amp. Now, some of the easiest preamp sections that we could make involve just an ordinary op amp. Now, an op amp signal looks like a triangle, and the standard way to hook these things up is with a bipolar power supply. What that means is that there's both a positive voltage and a negative voltage, each with respect to ground. With just two resistors and a bipolar power supply, you can set the gain for an op amp with these two resistors, because the gain is just the ratio of R2 to R1. Working with guitar effects and battery operated amplifiers, I use a single-sided power supply, which is ground and a positive 9 volt, at least positive 9 volt. And then what I do is I set a bias voltage somewhere in between, or as close as I can at that 4.5 volt mark. So what I do is I set up a bias voltage circuit between the positive reference voltage and ground using two resistors to get that middle voltage of about 4.5. And then I use some electrolytic capacitors, about 100 microfarads, sometimes more, to really steady things out. Now, in single-sided power supply mode, the op amp can be configured. It has a positive voltage coming in. It's got a ground going in where the negative voltage would normally go. We still use the same two resistors, R2 and R1. Ratio still gives us the gain, but now instead of running the positive input or the non-inverting input to ground, now I'm running it to the bias voltage. Okay, so what does that mean? It means that the signal has been pushed up and it's floating around that 4.5 volt mark. Now, the other mode that I use the op amp in, also with this single-sided power supply, is as a buffer. And it's okay to have the gain op amp feeding into the buffer, or you can have the buffer op amp feeding into the gain circuit op amp. The crucial thing that you have to do is you need to have some DC blocking capacitors on the very front end and the very back end, so you don't get any of that DC voltage bleeding out all over the rest of your signal chain. There's 3 different projects in the book. They're all about the same. So the first example is the transparent overdrive, which is a play on words because it's transparent. It has an op amp gain, which is adjustable by this volume knob. That feeds into an op amp buffer. And let's have an example of what that sounds like. The next project is what I call the 411 split gain. Doesn't have quite as much of the decibel boost that the transparent overdrive has, but it does have the adjustable gain. The input goes into that gain section op amp first, and then it goes into 4 separate buffers. So each of these is a buffered output. So this is what that sounds like. last up is the 4-into-1 mix down circuit, which is really the same two kinds of op-amp circuits. Only difference is you have 4 input signals here that are run through a volume knob, and then they're all added together in that initial gain stage. There is a variable gain here as well, and the sum of all that stuff gets buffered into this single output. So this is what that sounds like. So that's the 3 different op-amp circuits that I cover in the book. And one more thing, this is a tone stack and a volume knob that I made to throttle back the volume of the op-amp circuits if it was totally overloading the power amp, which, sometimes overloading is cool, sometimes it's not. We can go over. All I'm using it for in these examples was to throttle back the volume and, keep it from overloading the amplifier too much, because there's some good distortion, but there's also some ugly distortion. But that's it for right now, and I will catch you guys later.